Hello, ladies and gentlemen. Welcome back. Let's go ahead and start on Chapter 2. Chapter 2 is all about describing location in a distribution. And those of you who took advanced algebra last year, this is what we ended the year with those normal curves. So we're going to get into some of that. We're only going to touch on part of it in this lesson. All right, so let's get rolling here. First thing, please take time and read the case study again in your book, page 113. Read over that. Okay, it's all about the SAT test. So juniors, you should relate to, well, seniors too, you should relate to this because we are still planning on at some point taking that SAT this year. All right, so read over that. I'm not going to read it to you. You are all capable of reading that in your book. All right, I like their little cartoons here. All right, I can't speak for everyone in the top 1%, but I'm fine. All right, remember the normal curve, top 1%. All right, this you can skip in your book. Anything dealing with this, if I assigned a problem dealing with this, you can skip it. You don't need to know this. It will not be on the AP test. Any problems that deal with this, you may skip. Okay, so don't worry about that. All right, on page 125, it talks about the density curve. And again, remember, my expectations are for you to read. All right, minimum, reading the summary at the end of the book and reading the bolded letters in each chapter and the examples, minimum. All right, a density curve is a curve that, one, is always on or above the horizontal axis, and two, has area exactly one underneath it. A density curve describes the overall pattern of a distribution. Okay, remember we've talked about skewed left, skewed right. Okay, we're still talking about the overall pattern. That is one of the things we always do when describing a distribution, is talk about the pattern, because the pattern is telling us something. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that fall in that interval. We will get to that in the next lesson. Today we're just going to talk about the density curve and the properties of it. All right, so you know this is our density curve, and the area underneath the whole curve, always, the area underneath is always equal to 1. At some point in time, we will talk about the percents or decimals. Remember, 1 is 100%. Okay, 1 is the decimal equivalent of 100%. Don't forget that. All right, so how are density curves and relative frequency histograms, how are they related? Okay, well, here's an example, ladies and gentlemen, of tossing a coin 4 times. Here are the outcomes. Okay, so all tails, that would be the 0 heads. All right, let's see if I can color code this decent here. So these 4 tails, that would be 0 heads, right? And there are 16 outcomes there, ladies and gentlemen. And if I take 1 out of 16, I will get the decimal 0.0625. All right, so that means this is going up I know this says percent. Let's make this the decimal instead. 0.0625. All right, now if I take the next one, those are the outcomes of tossing a heads 1 time. Okay, well, that's 4 out of 16. Well, that one I hope is obvious. 4 out of 16 is going to be 0.25. Okay, so that means this is 0.25. All right, I'm going to quit going to the calculator. I'm just going to keep right on rolling here. So now there are 6 possibilities of tossing 2 heads. Okay, that's the blue right here. So 6 out of 16, that's going to be 0.375. All right, and then it starts to drop down again. So now 3 heads, there's 4 possibilities, so that's 0.25. And then all 4 heads, okay, that's going to be back down to 0.0625. Now, ladies and gentlemen, if you take all of those and add them together, okay, you add those together, what are they going to add up to? Oh, they're going to add up to 1. All right, so think of the normal curve. The area under the normal curve is always 1. The decimals of any relative frequency histogram, they're going to add up to 1 also. So, you know, this actually, if I connect the dots, and I have some more pictures I'm going to show you here in a second, you know, I can do this. Oh, look at that. It's perfectly normal. Okay, there aren't a lot of things that are perfectly normal in the world, but this distribution is perfectly normal. All right, so that kind of gives you a hint or an idea of what we're looking at. All right, let's keep going. All right, I've got some more pictures here. Again, where does the normal curve come from? What are normal curves used for? Again, it all begins with those histograms. Okay, now again, histograms aren't always going to be normal. In fact, most of them are not going to be perfectly normal. They might be close to normal, okay? Like these 2 in front of you, those are fairly normal. They're not perfect, but they are fairly normal because they kind of give us that normal single peaked curve, okay? And then on that one too. All right, so you can see here I've got some more pictures of how the histogram and the normal curves work. So eventually what happens, ladies and gentlemen, is you get so many bars in a histogram. You break it into so many pieces, eventually there's so many bars that you don't see the bars anymore and you see a nice normal curve like that. Okay, so that's what's happening. So the area, remember, underneath is always 1. Always, always, always. Now, I'm going to show you some pictures that look a little weird, but guess what? The area underneath them is always 1. So look at this one. It's a little bit weird. Okay, that is definitely not a curve, but ladies and gentlemen, this is going from 0 to 1. And this has a height of 1. Well, if you remember your geometry, the area is 1 times 1, which is 1. Okay, let's look at another one. Here's another odd looking picture. Definitely it's not a curve, but guess what? The area underneath is 1. The area underneath this, ladies and gentlemen, is 0.2. This one's 0.2. This one's 0.2. This one's 0.2. Okay, well that adds up to 0.8, right? And if you look here, let me switch colors here. This little piece right here, I could actually flip that over, and it could go right there. So that tells me that those 2 pieces together is 0.2. So the area underneath that is 1. All right, now some symbols. AP statistics is going to be full of symbols, and you need to keep them straight. If you use the wrong symbols on the AP test, that will lower your score. All right, so first of all, we have a population. Remember, a population is everybody. Okay, like the population of Columbia Heights High School. That would be all the students in the high school. The sample would be just like your class. Okay, if you're a junior, it could be just the junior class. If you're a senior, the senior class. Or it could just be those of you that are in my classroom. You're a sample, okay? Not a random sample. That's going to be important in the future as random sample. All right, so we got population and we got a sample. Now the symbols. Okay, for a mean, Greek letter mu. That is the symbol that we're going to use for a population mean. So if we're talking about the population, that's the symbol we need to use. If we're talking about the sample, we're going to continue to use X bar. Okay, that is for your sample mean. All right. Standard deviation, okay. Well, for the population, it is sigma, the Greek letter sigma. We use Greek letters to represent the populations, okay. That is the symbol we're going to use for a standard deviation of the population. Now remember what standard deviation is. Standard deviation is the average distance from the mean. Okay, it's representing the average distance from the mean. And we're going to be using standard, if you recall back to advanced algebra, we have to use standard deviation to find that z-score, which I'm not doing today yet, and then we have to look it up on that table. But I do have calculator way to do that stuff too, but that's coming up in the future, okay, not too far from now. All right, and then the standard deviation for the sample is just the S. All right, so don't get those symbols mixed up. Let's continue. All right, the empirical rule. Okay, you need to memorize this. Okay, again, you will recognize this from advanced algebra. Okay, we did it at the end of the year. Page 135. Okay, the 98 or 68, 95, 99.7 rule. All right, approximately 68% of the observations fall within one standard deviation of the mean mu. Approximately 95, notice it's approximately, okay? These approximations are good in AP statistics, okay? So these are easier to work with than trying to remember those decimals. Approximately 95% of the observations fall within 2 standard deviations of the mean, and approximately 99.7% of the observations fall within 3 standard deviations of the mean. All right, and here is a picture of it. Okay, remember the power of pause and rewind if you need to pause it. Okay, but I'm gonna pull up the advanced algebra one that we used. So it's a little bit more detailed. Okay, here it is. It's not the best picture. You may want to draw a nice picture in your notebook. All right, this one's a little bit more detailed. You'll notice that this one goes a little bit further. It says 1 standard deviation below to 1 above is 68.2. But we could, ladies and gentlemen, just use the 34%, which is 0.34. Same thing here. Okay, so we can drop that part off. Okay, you don't have to if you don't want to, but I'm just saying that you can do that. It's a little easier to remember 68 and then 34, 34, 1 below to the mean and the mean to 1 above. All right. Okay, and then we can also do that with the 95. We can leave that 0.4 off. Okay, so if that's the case, then the 13.6 would no longer be 13.6. Okay, that would be 13.5%, and the decimal for that would be 0.135. Okay, that is, again, if we're just going to use the 95%. It doesn't matter which one you decide. I will accept both, but pick one and stick with it. Don't flip-flop back and forth. Okay, so if we go with the 95%, that's what that would be. Okay, but then that means the 2.15% would also change. That would no longer be 2.15%, that would be 2.35%, and the decimal for that would be 0.235. Okay, so pick one of them and stick with it, although we will be using our calculator after I show you how to use that a lot with this, okay? And then we do have just a teeny bit left in the tail. If you remember, this has to add up to 1. So in the tail, this would be 0.15%. And the decimal for that would be 0.0015. Same thing on the other side. This would be 0.15%, and the decimal for that would be 0.0015. And if you add those decimals up, they do add up to 1. All right, so you can either use the old one or go with the 68, 95, 99.7, and then you have to adjust a little bit. And I would memorize these. Again, from the mean, 1 above is 34%. Okay, from 1 above to 2 above, that's 13.5. Okay, remember, for the tests you're taking with me now, yeah, you're going to have all the open book stuff that you need and stuff when you take the test. But when it's going to come to the AP test in May, you're not going to have all of those notes in front of you. You will have the formula chart and tables in front of you, but you're not going to have all these extra. And they don't give you a picture like this on the AP test. Okay, but they do give you that table that we're going to use later. All right. All right. So one more thing with this, when the standard deviation is larger, the normal curve is going to be flatter. Okay, the bigger the standard deviation, the more spread out it is. Okay, and it's flatter. If the standard deviation is smaller, the normal curve is going to be taller. And it's going to be less spread out. Okay, keep that in mind. Bigger standard deviations, more spread out, flatter. Small standard deviations, it's going to be taller and less spread out. But the area underneath, remember, is always 1. All right, where is the mean and median on a density curve? Well, it depends on the picture, and we already did this in chapter 1 with the histograms. Okay, so this will be, we've got a balancing point and an equal area point. All right, so if it's perfectly normal, okay, the mean and the median are exactly the same. Okay, the mean and the median are right in the center. Okay, however, if it's skewed to the right, remember the mean is going to be bigger than the median. Now remember, the median is the halfway point. So to the left of the median is 50% of the data. To the right of the median is 50% of the data. All right, but the mean, that doesn't work with the mean, that only works with the median. But skewed to the right, the mean is to the right. The mean is bigger than the median. All right, and you can see here, okay, the mean is the balance point. Okay, the mean is the balance point. But that doesn't, remember, the mean, that's not necessarily 50% to the left, 50% to the right. Okay, if it's skewed to the left, remember, let me go back a second. If it's skewed to the left, ladies and gentlemen, well, I can do a better job than that, I think. Okay, here we go. If it's skewed to the left, the mean is going to be smaller than the median, because the median, again, is 50% to the left, 50% to the right. So the mean, that's probably a little bit too far. The mean's going to be like over here somewhere, but it's going to be to the left. All right, get all of those things straight in your brain. All right, that is it for this lesson. That was long enough because that was almost 20 minutes. All right,